What if your fitness tracker actually stuck to you like a post-it, only without peeling off mid-squat? Unlike most stickers, this hydrogel sensor actually sticks around. As a researcher, today you'll see how engineers turn seaweed and a 3D printer into a self-adhesive rubbery hydrogel that clings to your skin like a second layer. Wearable sensors often tear, lose grip when you sweat, or irritate your skin after a few hours, leading to data dropouts, wasted workouts, and a lot of frustrated users. Imagine sprinting on a treadmill or powering through a spin class, only to discover halfway through that your heart rate patch has folded in half, your data's gone, and so is your motivation. What if we could build a sensor that's soft, stretchable, sweat-proof, and biocompatible? That's what a team of 14 researchers asked. A sensor that doesn't slip, peel, or skip a beat. And that's exactly what they did. They kicked things off by grafting tiny hooks, methacrylic groups, onto a seaweed sugar called kappa-carrageenan and blending in a rubbery monomer. They poured that mix into a light-based 3D printer, building each sensor patch layer by layer. To get the perfect bounce back, they tuned two glue systems. One that holds strands together like intertwined shoelaces, and another that locks them in place like super strong tape. Then they slapped these patches onto a dummy arm that sweats and watched them cling tight for hours. No peeling or red marks, just like a waterproof bandage you never notice. Finally, they hooked the patch up to a small computer brain that watches how its shape changes. What they discovered was impressive. These hydrogel sensors can stretch 100%, doubling their length, and still snap back perfectly over hundreds of cycles, proving they won't tear under real-world use. In biocompatibility tests, L929 fibroblast cells showed near 100% viability after 48 hours in contact with the hydrogel, confirming it's safe for prolonged wear. When placed into a neck motion patch, a lightweight neural network decoded flexion, extension, and rotation with over 80% accuracy, demonstrating real-time, reliable motion tracking. Now, I think this paper was a big step in wearable sensors. It would be cool to validate this sensor in real-world conditions by running long-term human wear trials, monitoring adhesion strength and skin response over several weeks under everyday activities. And now, the meme of the week. If you enjoyed this sticky soft sensor, hit subscribe and ring the bell to stay in the loop. Don't miss our next deep dive on spider silk reinventing sensors. Thanks for watching, and I'll catch you in the comments.